This is Shanfeng Zhu from Fudan University. Actually, as we all know, metagenomics is a very important area with many applications. There are several important computation problems in metagenomics, including sampling, quantitative binning, and taxonomic assignment. We focus on the quantitative binning, which aims to group genomic fragments from the same genome into the same bin. So metagenomic binning is a culture-free approach to discover and study new genomes and new genomic features. Actually, in the last 2 or 3 years, we have developed two very important binning methods. One is MetaBinner. The basic idea is using the ensemble learning and try to using different types of feature, combining single copy margin and k-means for generate high quality and diverse component binning result. After that, we try to integrate them to obtain a final result. MacBinner achieved good performance in coming tools challenge, especially on the Maria and the string matrix dataset. And the other method we developed last year is COMBIN. The basic idea of COMBIN is using contrast learning. The most important of COMBIN is to try to carry out data augmentation, where the fragments from the same context should be grouped into the same bin, and they should be positive pairs in the contrast learning. After obtaining good representation of context, latent is used to group these contexts. So actually, early this month, the CAMI benchmark portal comes out, and COMBIN achieves the first place in the Maria dataset. Anyway, we can say, although many binning tools have been developed, existing studies have not considered the various combination of data type and binning models. For example, CAMI2 focuses on the simulated data. So therefore, we focus on the real data set in the benchmark study and introduce seven data binning combinations by integrating short read, long read, and hybrid data with core sampling, single sample and multi-sample binning modes. And we benchmark 13 metagenomic binning tools across these combinations. Here is the overview of our benchmark study. Firstly, we collect 202 samples from the 5 datasets, covering 4 elements and 3 sequence platforms. Then we introduce several data binning combinations. And finally, we benchmark 13 benchmark tools, followed by analysis of mags recovered from these combinations. So here are the details of our benchmark datasets. 5 real metagenomic datasets were used in this study based on the follow consolidations. The dataset or sequence utilized both short read and long read technologies, thereby meeting the requirement of our benchmark across 7 data binning combinations. Secondly, the dataset were collected from diverse elements, enhancing data diversity and ensure more reliable benchmark results. Thirdly, the dataset were publicly available, ensure the feasibility of benchmarking and the reproducibility of study. And our contributing studies introduced several data binning combinations. And this table summarizes the this kind of data type assembly strategy and binning mode associated with each data binning combinations. In this study, we benchmark 13 metagenomic binning tools, including the Concord, MaxBin2, and MetaBet2, CMB MetaDecoder, binning, MetaBinner, SunBin2, COMBIN, and also 3 bin refinement tools, DS tool, MetRep, and MaxCode. So here are the benchmark results. Actually, we evaluated 10 binner across 7 data binning combinations using 5 datasets. For each combination, we calculate the average number of sampling covered associated genomes recovered by each binner. We focus on 3 types of mags: high quality mags, new completed mags, and mid quality mags. For example, the new completed max standard for the completion is larger than 19% and the contamination less than 5%. Actually, there are 5 rows standard for 5 data sets, and each column standard for high quality max, unsafe quality max, and medium quality max, respectively. From the result, we have 3 findings. First, the multi-sample binning consistently achieved the best performance across short-read, long-read, and hybrid data. Secondly, short-read data performed poorly in recover high-quality max. And thirdly, hybrid dataset outperformed both short-read and long-read datasets. Here is an example result for the hybrid data. Actually, we can see some binner exhibit notable performance difference across various data binning combinations. For example, the metadecoder achieved the 2nd place in hybrid single, but 4th place in hybrid multi. And also, binning achieved the second place in hybrid multi, but the 8th place in hybrid single. So we try to, for the ranking, so we try to calculate the overall ranking score across different data set, different data binning mode compilation. So the overall rank score reflects performance on mid-quality, near complete, and high-quality matrix across all data sets. Based on needs, we list the top 3 high-performance binner for each combination, along with the efficient binner. So the actually, for the high-performance binner under different scenarios, 5 of them are very good: CAN-bin, MetaBinner, SIMBin2, binning, and metadecoder. For the concerning the memory usage and running time, MetaBinner2, FMB, and metadecoder are highlighted as efficient binner. We also check the performance of bin refinement tools. Actually, the results, MATLAB achieved the best all average ranking score, where MaxScore achieved the comparable score, but with excellent scalability. And then we analyzed the result. We found that the binners with top overall score reveals extensive microbiome diversity. And also, multi-sample binner recover the species and strains across, have a better recover the species and strains across data type. We identified the partition allergy host and the BGC in new complete strains from the marine dataset. The figure shows that the number of partition allergy hosts, multi-resistant allergy hosts, BGC, and the level BGC identified across the 7 data binning combinations. The result demonstrated the multi-sample binning refers extensive potential allergy hosts, BGC, across diverse data types. So finally, the summary, we introduced 7 data binning combinations by integrating short-read, long-read, and hybrid data with co-sampling, single-sample, and multi-sample binning respectively. Our benchmark shows that the multi-sample binning exhibit the optimal performance, and the multi-sample binning outperforms other binning modes in identifying partition allergy and BGC. Also, we found the CAN-bin, MetaBinner, SIMBin2, binning, and metadecoder are highlighted as high-performance binner. MetaBinner2, FMB, and metadecoder highlighted as efficient binner. I would like to thank my student Haitao and Ziye conducting this benchmark study, and also like to thank my collaborator in USA, Professor Feng Zhu. So all the code and data can be available from the GitHub. And also, I would like to ask you to try maybe binner and CAN-bin for your dataset. Thank you very much.
Thank you very much. Again, time for one quick question. Hi, thanks for the very good it seems that like multi-sample binning is a clear way to go, but did you have an opportunity to explore either when this multi-sample approach start like being have like advantage in terms of the samples that are being used, or in terms of the depth of the sequencing?
Pardon?
So it seems that multi-sample binning.
Multi-sample binning, yes.
It's like it has like a clear advantage compared to single sample binning.
Yeah, yeah.
But I wonder if you have the opportunity to explore how many samples do you need to have?
Oh, you mean
Or, for example,
how many samples?
And the second question would be how much in depth the sequencing could be.
Oh, so in our data set, actually here is the number of samples we use. Actually, I think maybe we didn't check it very carefully, but anyway, I think maybe should be a few, maybe 5 or 10. Yeah, we didn't check it very. We didn't carry out the systematic experiment to see how many samples we need. Yeah.
For example, it seemed like did you see that like the human gut tube is like 30 samples?
Yeah, but anyway, if you have more samples, the result will be more significant. Yeah.
Okay, thank you very much.
Thank you.
Thanks.